In this video, we're going to expand and simplify expressions that involve polynomial expressions that are squared. Many times these are referred to as a special product because they have a specific pattern. As we look at multiplying these, though, we'll rely on the techniques we've already learned of distributing using the FOIL method of finding the first, outside, inside, and last terms. Once we've done that, we'll summarize these special patterns and look at how we could do them more quickly in the future. So let's look at this first one. We have the expression t plus 4, and that expression is squared. It's important as we look at this that we look at where the parentheses and the square are. So here, the entire expression t plus 4 has been squared. In the next example, we'll look at one where the entire expression is not squared, so we're going to pay attention to that. To start, the quantity t plus 4 squared can be written as t plus 4 times t plus 4. And once we do that, then we can use that standard FOIL method of distributing. So, looking at multiplying t plus 4 times t plus 4, the first term will be t squared. We have t times t. And then when we multiply those outside terms, we're multiplying t by 4. So we'll have plus 4t. Multiplying the inside terms, we'll again have plus 4t. And then multiplying the last terms, we'll have 4 times 4. Now, when we simplify that, we'll get t squared. Those middle two terms, we have 4t plus 4t, so we'll have plus 8t. And then that last term is 4 times 4, so plus 16. So that expression, when fully simplified, is t squared plus 8t plus 16. Going to our next example, we have 2, and then we have the expression 4y plus 3 squared. It's critical to note here where those parentheses fall. They're surrounding 4y plus 3, and then the squared is outside of that. So we're only going to square 4y plus 3. The 2 is then something that we multiply that expression by. So thinking of our order of operations, we'll do that expansion of that exponent first, and then we'll multiply through. So if we write this out, we have 2, and then we have that expression 4y plus 3 squared. So I'm going to write 2, and then I'll have 4y plus 3 times 4y plus 3. Now at this point, I can use the associative property of multiplication one of two ways. Remember that that property says that if I have A times the quantity BC, then that's equivalent to AB times C. So here, I could multiply that 2 times 4y plus 3 and simplify that, and then multiply that expression by 4y plus 3. Or I could choose to multiply 4y plus 3 by 4y plus 3 first. And I am going to do that here. Because they're the same expression, that multiplication will be a little bit easier. So, going through, again, I'm going to multiply this 4y plus 3 times 4y plus 3 first, and as I do that, I'll just leave this 2 out front. So, multiplying that through, 4y plus 3 times 4y plus 3, the first term, that when I multiply the first term of each of those binomials, I'll get 4y times 4y. Multiplying the outside, I'm going to get 4y times 3, so I'll write plus 3 times 4y. The inside, I'll again get plus 3 times 4y. And then the last, I'm going to have plus 3 times 3, or plus 9. Now, I'll simplify what I have. So 4y times 4y gives me 16y squared. 3 times 4y is going to give me 12y. And 3 times 4y again gives me 12y, and then I have plus 9. So at this point, I have 2 times, and then this expression, 16y squared plus 12y plus 12y plus 9. The next thing I want to do before I distribute this 2 across is to combine those like terms of 12y and 12y. So when I do that, I'll have 2, and then times the expression, 16y squared plus 24y plus 9. Now at this point, I'm almost done. The last thing that I want to do is distribute this 2 across those 3 terms. So when I do that, distributing the 2 to 16y squared, I'll get 32y squared. Distributing that 2 to 24y, I'll get plus 48y. And then distributing that 2 to 9, I'll get plus 18. So that expression, when fully simplified, is 32y squared plus 48y plus 18. The next two examples that we're going to look at involve subtraction. this first one we have is the expression 6x minus 5 squared. So that entire 6x minus 5 is squared. So I will turn that into 6x minus 5 times 6x minus 5. And now I can multiply the first terms. I'll get 6x times 6x. And then the outside, I have 6x, and then that term is negative 5. So I have minus 5 times 6x here. And then the inside, I'm going to have the same thing, minus 5 times 6x. And then the last, I have negative 5 times negative 5, which I can write as plus 25. So at this point, I have 6x times 6x minus 5 times 6x minus 5 times 6x plus 25. I'll simplify each of those terms, and then I'll combine like terms where I can. 6x times 6x is going to give me 36x squared. I'm now subtracting 5 times 6x, so I'm subtracting 30x. And I do that again, so minus 30x, and then plus 25. So I have 36x squared minus 30x plus 25. The last thing that I want to do here is combine like terms. Minus negative 30x and negative 30x are like terms. So when fully simplified, this expression will be 36x squared minus 60x plus 25. The last expression that I have here is 9 minus 1/2 t, and that quantity is squared. So again, paying attention to where these parentheses fall, 9 minus 1/2 t, that's the quantity that's been squared. So I can turn this into 9 minus 1/2 t times 9 minus 1/2 t. And so looking at multiplying using the FOIL method here, I'll take 9 times 9 for the first two terms. And then my outside, I have 9 and then negative 1/2 t. So I'll have minus 9 times 1/2 t. And then I'll have the same thing for the inside terms. I'll have minus 9 times 1/2 t. And then those last terms, when I multiply them, are going to be negative 1/2 t times negative 1/2 t. So I can do plus negative 1/2 t times negative 1/2 t. And note that the multiplication of those two negatives will become a positive. So I could change it at that point if I really wanted to. Simplifying here, 9 times 9 is 81. So I have 81. And then 9 times 1/2 t, that's still going to be a rational expression. So I'll have minus 9 halves t, and then I'll have that again, minus 9 halves t. And then I'm adding, so I have negative 1/2 times negative 1/2 will give me positive 1/4 for the coefficient, and then t squared. So at this point, I have 81 minus 9 halves t minus 9 halves t plus 1/4 t squared. Simplifying those two middle terms, those are like terms, and so I can turn this into 81 minus, and then depending on how much fraction math I want to do, I'll probably turn this into minus 18 halves t plus 1/4 t squared. And then as a last step, that subtracting 9 or 18 halves t can be subtracting 9t. So this expression, when fully simplified, will be 81 minus 9t plus 1/4 t squared. And one thing to note is that in general, we write polynomial expressions in descending order. So I could also write this as 1/4 t squared minus 9t plus 81 if I wanted that t squared term first. Finally, let's summarize what these special products, how these special products work. So I've inserted here two formulas, and the first says that the quantity a plus b, 1 squared, is a squared plus 2ab plus b squared. And similarly, the quantity a minus b, 1 squared, is equivalent to a squared minus 2ab plus b squared. So we've seen this in these examples that we've done, and these can be used to shorten the multiplication that we do. So if we look at our first example, quantity t plus 4 squared, if we look at this middle step, we have t squared plus 4t plus 4t plus 4 times 4. And so we essentially have t squared plus 2 times 4t plus 4 squared. And that's what's giving us t squared plus 8t plus 16. Similarly, if we look at this quantity 6x minus 5 squared, and we look at that pattern shown in the formula, in that one of those middle steps, we see this 6x times 6x, which is quantity 6x squared, and so that was our a. And then we see minus 5 times 6x minus 5 times 6x. And so because those a and b repeat, we're getting minus 2 times that 5 times 6x. And we see that when we combine like terms. And then that last term, we're seeing b squared essentially. And so when we're taking negative 5 and squaring it, we're getting that 25. So we can see that pattern there, and then when it's fully simplified, we get 36x squared minus that 60x plus 25.